Have you ever wondered how your favorite software stores and manages data? Today, we're going to delve into the world of arrays, a fundamental data structure used in computer science and programming. An array, in simple terms, is a collection of elements, say, numbers or characters, stored in contiguous or neighboring memory locations. Each of these elements is identified by a unique index or key. Think of it as a neatly organized drawer where each compartment has a unique number and contains a specific item. This structure allows us to access and manipulate data in a highly efficient manner, making arrays an essential tool in any programmer's toolkit. From the simplest applications to complex algorithms, arrays serve as the backbone for data storage and management. So, remember this: arrays are a fundamental tool for efficiently storing and accessing data. Arrays are known for their unique features. Let's delve into those features that make arrays stand out in the world of data structures. An array's first key feature is its fixed size. When you declare an array, you also determine its size. This size stays constant throughout the program's execution. So, if you initiate an array with a capacity for 10 elements, it will always have room for 10 elements, no matter what. Next up, we have index-based access. Each element in an array has a unique identifier called an index. This index helps us locate the element's position within the array. Interestingly, array indexing starts from 0, so the first element of your array is always at the 0th index. The third characteristic of arrays is the ability to support random access. Random access means you can directly retrieve any element in the array just by knowing its index. This feature enables constant time complexity, making arrays a highly efficient data structure for accessing data. Now that we've covered the key features, let's transition into the operations that can be performed on arrays. Arrays support insertion and deletion, meaning you can add or remove elements at specific positions. However, keep in mind that these operations may involve shifting of other elements, leading to linear time complexity in the worst-case scenario. Traversal is another operation supported by arrays. It allows you to iterate over all elements sequentially, typically using loops such as for or while. Lastly, arrays enable various manipulation operations, including sorting, searching, and updating elements. You can use sorting algorithms like bubble sort or quick sort to order your elements, or searching algorithms like linear search or binary search to locate specific elements within the array. These features make arrays a versatile tool for managing data. They provide programmers with a fixed size, efficient data access, and a set of operations to manipulate data, making arrays a fundamental building block in data structures and programming. Arrays support various operations that allow for efficient data management. Let's delve into these operations to gain a better understanding. First off, we have the insertion operation. This allows us to add a new element at any position within the array. However, since arrays have a fixed size, this operation may involve creating a new array or shifting existing elements to make room for the new one. It's like making space for a new book on a full bookshelf. Some books will have to be moved around. Next up is deletion. This operation is the reverse of insertion and involves removing an element from the array. Similar to insertion, deletion may also require shifting elements to fill the gap left by the removed element. It's like taking a book out of the bookshelf and pushing the remaining books together to close the gap. Now let's talk about traversal. This operation involves visiting each element in the array, one after the other, from the first to the last. It's like reading all the titles on your bookshelf, one by one. Traversal is often used in combination with other operations, such as searching or sorting, to process each element in the array. Speaking of sorting, let's move on to manipulation operations. These include sorting, searching, and updating elements. Sorting an array involves rearranging its elements in a specific order, either ascending or descending. It's like arranging the books on your bookshelf alphabetically. There are various sorting algorithms, each with its own advantages and trade-offs. Searching, on the other hand, involves finding a specific element in the array. It's like looking for a particular book on your bookshelf. The efficiency of searching depends on whether the array is sorted or not. If it's sorted, binary search can be used, which is more efficient than linear search used for unsorted arrays. Lastly, updating an element involves changing the value of an existing element in the array. It's as simple as replacing a book on your bookshelf with a new one. It's important to note that the efficiency or time complexity of these operations can vary. Some operations, like random access and updating, are fast and take constant time. Others, like insertion and deletion, can take longer as they may require shifting elements, especially in large arrays. In the end, these operations on arrays provide programmers with a versatile tool for data management. They enable efficient storage, access, and manipulation of data, which form the backbone of many applications in computer science and programming. To wrap up, arrays with their simple structure and various operations are a fundamental data structure in programming. Whether it's adding a new element, deleting an existing one, traversing the entire array, or manipulating the elements, arrays offer a wide range of possibilities for managing data. These operations enable programmers to effectively manage and manipulate data in their applications. Arrays find extensive use in a wide range of applications. They are the workhorse of many software applications and are heavily utilized in various domains. Let's explore some practical applications of arrays in programming. Firstly, arrays are used to store and manage data. They can hold multiple values of the same type, from simple data like numbers and characters to complex data types like objects and structures. This makes arrays ideal for scenarios where you need to handle multiple items of similar data, such as storing student grades, employee salaries, or product prices. Secondly, arrays serve as the building blocks for various algorithms. This is because they provide random access to elements, which allows algorithms to operate efficiently. For instance, sorting algorithms like quicksort, merge-sort, and heap-sort rely heavily on arrays to sort elements in a specific order. Similarly, arrays are used in searching algorithms like binary search and linear search to locate specific elements within the array. Thirdly, arrays are used to implement other data structures. For instance, stacks and queues, which are fundamental data structures in computer science, are often implemented using arrays. The efficiency and simplicity of arrays make them an excellent choice for representing these more complex structures. Finally, arrays are used in multidimensional data representation. They can be used to create two-dimensional arrays, three-dimensional arrays, or even higher dimensional arrays. This makes them ideal for tasks that require multidimensional data, such as representing matrices in mathematical computations, storing pixel data in image processing, or managing game boards in game development. In these ways and more, arrays prove their worth in a variety of practical programming scenarios. They provide a simple, efficient, and versatile means of storing and manipulating data. Their ability to facilitate efficient algorithms and act as the backbone for other data structures further underscores their importance in programming. The versatility of arrays makes them a staple in any programmer's toolkit. Whether you're a beginner just starting out or a seasoned professional, understanding and effectively utilizing arrays will undoubtedly elevate your programming skills. Let's recap what we've learned about arrays. As we've explored, arrays are a fundamental data structure in computer science and programming. They're essentially collections of elements, all snugly stored in contiguous memory locations, each identifiable by a unique index or key. We've seen that arrays come with several key features. They have a fixed size, determined at the time of declaration, which means the number of elements remains constant throughout the program's execution. Each element in an array is accessed using its index, which starts from 0 for the first element. Additionally, arrays support random access, allowing you to retrieve elements directly using their index, leading to constant time complexity. Moving on to operations, arrays are quite versatile. They support insertion and deletion operations, enabling you to add or remove elements at specific positions. But remember, these operations might require shifting elements, which could lead to linear time complexity in the worst-case scenario. Arrays also allow for traversal, which means you can iterate over all elements sequentially. This can be done using loops such as for or while loops, accessing each element one by one. Plus, arrays support various manipulation operations, including sorting, searching, and updating elements. Sorting algorithms like bubble sort, insertion sort, or quicksort can rearrange elements in ascending or descending order, while searching algorithms like linear search or binary search can locate specific elements within the array. In terms of practical applications, arrays are everywhere. They're used in sorting algorithms, search algorithms, and data manipulation algorithms. They're also used in various data processing and analysis tasks, making them an essential tool for programmers and data scientists alike. In conclusion, arrays are a powerhouse of functionality. With fixed size, efficient random access, and support for a wide range of operations, they offer a robust way to store, access, and manipulate data. Understanding arrays can help you become a more efficient and effective programmer. Thanks for joining us on this exploration of arrays and data structures.